What do you know about the multiverse?
Viz had his theories. He believed it was dangerous.
The idea of infinite worlds existed since the time of ancient Greek philosophers, but it has been created into a valid scientific hypothesis only through the lens of modern physics. Multiple universes have been hypothesized not only in cosmology, but also in many works of science fiction, where they are better known as parallel universes or dimensions, alternative realities, and so on. But do any of them hold water? If the multiverse is real, does it mean you exist an infinite amount of times throughout these parallel worlds?
We wondered, what would identity mean?
There are many ways to the multiverse. Maybe a good place to start would be what I consider the simplest of all, which is to imagine the possibility that space goes on infinitely far, right? If you were to get into a rocket ship and head out into the cosmos, would you at some point hit a brick wall? No, most of us don't think that's the case. Would you circle back to your starting point, like what would happen on the Earth's surface if you took a similar journey? That's possible. Or would you simply keep on going forever? We don't know, but let's take that third possibility seriously. If we do, there's a startling conclusion, and it's simply this. In any finite region of space, matter can only arrange itself in finitely many different configurations. Similarly, like if I take a deck of cards. If I shuffle the deck, the order of the cards differ. There are only finitely many different orders of the cards, many different orders, but finitely many. So if I shuffle the deck enough times, infinitely many times, the order of the cards has to repeat. Similarly, in infinite space, the order of the particles, the configuration of particles has to repeat too. Now, what would that mean? Well, it would mean something pretty strange. You see, you and I were just the configuration of particles, as is the Earth and the Sun and so forth. If the configuration of particles repeats someplace out there in the cosmos, it means all that we know is repeating.
The fundamental theory that describes the behaviour of subatomic particles, quantum mechanics, might imply not only are there multiple identical versions of you, but even that there are an infinite number of yous out there. How could that be possible, you ask? The quantum realm is notoriously counterintuitive, where quantum objects, such as particles, are described in terms of probabilities, encoded in mathematical descriptions called wave functions, which give you the odds on any number of different states a particle might be in. Only when you observe or measure does the object take on one of these given states. But what does it have to do with multiple universes and infinite copies of you? Theoretical physicist Brian Greene has discussed 9 types of multiverses. One of them is the quantum multiverse, which creates a new universe when a diversion in events occurs, as in the real world's variant of the many worlds interpretation of quantum mechanics. The many worlds interpretation implies that there are most likely an uncountably infinite number of universes. It views time as a many-branched tree where every possible quantum outcome is realized. This is intended to resolve the measurement problem and some paradoxes of quantum theory, such as Schrödinger's cat, since every possible outcome of a quantum event exists in its own universe. Another type of multiverse in which you might exist in infinite amount of times is the so-called quilted multiverse, but it works only in an infinite universe with an infinite amount of space. Every possible event will occur an infinite number of times. But do we really know we live in an infinite universe?
So there is an incorrect image that many people have in mind, which is this. When we think about the Big Bang, typically we imagine that further and further back in time, the entire cosmos was smaller and smaller and smaller, and way back toward the beginning, the universe we sort of intuitively think of as very, very small, and then run that film forward, space is created from that Big Bang, so how could it ever be infinitely big? And if that were the right picture, but that was not the picture that's compatible with an infinite universe. In an infinite universe, as you head ever further back in time, the universe is still infinitely big. If you go back in time and the universe is half as large as it is today, half of infinity is still infinity. The Big Bang is an event that gave rise to our realm, but if the universe is infinitely big, then our part, the part that we have access to, is only a piece of the entirety. So you need to make a distinction between the observable universe and the entirety. The observable universe is just the part that we can see. We can't see further back than roughly 13.7 billion light years because that's the amount of distance that light can travel since the beginning. Sure. But almost nobody believes that the universe ends at that point. Most everyone believes it goes on at least a far distance beyond that. And the supposition of this particular example that we're saying is that it goes on infinitely far.
In another type of multiverse called the brain multiverse, our entire universe exists on a membrane, or brain, which floats in a high dimension, or bulk. In this bulk there are other membranes with their own universes. These universes can interact with one another, and when they collide, the violence and energy produced is more than enough to give rise to a Big Bang. The brains float or drift near each other in the bulk, and every few trillion years, attracted by gravity or some other force we do not understand, collide and bang into each other. This repeated contact gives rise to multiple or cyclic Big Bangs.
Look, if each one of those spheres represents a universe, that means that each one of those spheres has its own Big Bang, if you will. Now, how did it all get started from the get-go? Nobody knows. But when we talk about Big Bang in the context of a multiverse, we're really talking about multi-Big Bangs. Each universe has its own Big Bang, giving rise to its own expanding portion of space. But the different universes have distinct Big Bangs, and therefore the Big Bang did not start off the whole thing. Rather, the Big Bang is the name that we give to the process that yields our expanding universe. That is the difference between them. And that's the language that we typically use.
A hypothetical universe model is that an extension of the Big Bang theory is eternal inflation. According to this theory, the inflationary phase of the universe's expansion lasts forever throughout most of the universe. Because the regions expand exponentially rapidly, most of the volume of the universe at any given time is inflating. Eternal inflation, therefore, produces a hypothetically infinite multiverse.
The discoverers of this inflationary cosmology realized a couple of years after the initial discovery something quite interesting. This kind of inflationary burst is likely not to be a one-time event. There can be many of these inflationary bursts. In fact, the picture which I like to have in mind is like a big block of Swiss cheese. And what I mean by that is if this Swiss cheese is this energy that's suffusing space, the idea is the cheese expands, but in various locations, the energy dissipates and creates a little opening, a little bubble that then grows over time. And the idea is that all of the little bubbles in the cheese are different universes, our universe being one of those bubbles. That's the way in which many, many universes come out of this inflationary cosmology. The universe is expanding. This is creating a repulsive gravity, pushing everything apart. But at various locations, pockets open up, regions where the energy has dissipated and turns into more ordinary particles of matter and radiation. So these would all be, in this picture, different universes created within this vast expanding object. We call this the multiverse. Now, if we go into one of these, it looks, once you penetrate it, just like an ordinary universe, like our universe. So here is our universe. Just one bubble. The fact that it's a bubble, it looks small from the outside. It's not. It's huge from the inside. This could be our universe. Now, if we exit, if we go into another bubble, the world, the physics can be a little bit different. The features do not have to be identical to ours. So all of these different worlds, all of these different universes would be out there embedded in this vast, expanding, gaseous realm, with our universe simply being one of the bubbles among many. So the idea is, if this picture of the universe is correct, and we could take, say, the grandest view of the multiverse, we would see a vast assortment of worlds where various nuggets of reality would play themselves out world by world as they evolve and change, as they go forward and back, as they grow in size. The universe, in some sense, would be this vast assortment of little bubbles, with our universe being but one melodic line in this richly textured cosmic score.
Perhaps the most fascinating type out of the 9 types of multiverses Brian Greene discusses is the simulated multiverse. This multiverse exists on complex computer systems that simulate entire universes. A related hypothesis, put forth by astronomer Avi Loeb, is that universes may be created in laboratories of advanced technological civilizations who have a theory of everything. But more on that in another video. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.